For those of you just joining us, welcome. Kate Patterson will share her expertise with Sensor Tracker, a software package built by CEOTR to manage metadata used in data processing pipelines. Kate, over to you.
Great, thank you, Laura. Good morning, everybody. Thank you for joining us, and thank you to Meopar and Ocean Gliders Canada for organizing this. As she mentioned, me and Adam are here today, and we're both very familiar with the software. So if you have any questions at the end, please go right ahead. I have a pre-recorded video here, so you'll notice it starts with "in this video," and that's why we're doing questions at the end. So I'll just go ahead with that now.
In this video, we will be discussing a free software package built by our team at CEOTR for managing scientific research metadata and instrument tracking for multi-parameter platforms such as autonomous ocean gliders. First, some information about our team. CEOTR is the Coastal Environmental Observation Technology and Research Group, which is a collection of people experienced in instrument support, field logistics, glider operations, and data management based at Dalhousie University in Halifax, Nova Scotia, and funded by several agencies, as you can see below. This project started 3 years ago as a metadata tracking solution, initially to meet the needs of our glider team, but has since expanded to our other projects, including Bedford Basin weekly time series sampling and benthic pod intrusion study. Metadata is important for the proper cataloging and preservation of primary data. Without metadata, the primary data cannot be used outside of the group that collected it. Metadata can take many forms and is not limited to the types I've listed here. For most oceanographic work, the field team records time, place, local conditions, and the like. But there's much more that needs to be known, including which instruments are being deployed, what are the settings on those instruments, why are they being deployed, and on and on. Depending on an ad hoc field notebook to record all of this critical information is not the best plan. So to aid our busy field team, we have developed a software package that we call Sensor Tracker. So what exactly is it? This is a software package for managing metadata used in data processing pipelines and for informational purposes. It includes a database, a web-based user interface, and an API for accessing JSON formatted metadata collected from platforms, instruments, and sensors. This technology stack includes a Postgres database to store the metadata and the application data, the Django web framework, which is written in Python to both serve a website for viewing and manually editing the metadata, and to serve a RESTful API for the JSON formatted data. So a RESTful API is an application program interface that uses HTTP requests to create, retrieve, update, and delete data. Also, JSON is JavaScript object notation. You'll see some examples of this later on. And finally, a Python library for programmatically accessing the API, which could be used as part of a data processing pipeline. Why did we make it? As I mentioned earlier, this was initially built with the needs of our glider team in mind, though we have aimed to keep our metadata models generic enough for other applications. In our early glider data processing pipeline, metadata for our datasets was populated by reading from static files, like CSV files. While that approach was difficult to manage for a number of reasons, a major issue that motivated us to build this was tracking equipment configuration. As our glider fleet grew and we started swapping instruments between between platforms, sometimes mid-mission, and occasionally swapping sensors on our instruments, it became increasingly difficult to track these changes. So in addition to recording information about sensors, instruments, platforms, we also track the relationships between them, when a sensor was attached to an instrument, when an instrument was attached to a platform, and which platform was used in a platform deployment. These records allow us to automatically include relevant metadata in our process data files. So how are we using it on our team? We add metadata to Sensor Tracker both manually and automatically. The web interface is mainly used by our field technicians to manually enter information about our equipment. Our data processing pipelines also automatically add equipment and relationships between equipment if it does not yet exist in Sensor Tracker, which can later be edited manually to include more information. Log entries are generated for manual and automated changes, making it easier for us to detect errors and incomplete information. We don't currently have a mechanism for rolling a model back to a previous version, instead referring to log entries to manually revert, but this version control functionality could be made available through existing Django libraries. Sensor Tracker has significant use in our data processing pipeline. Using a Boolean flag to indicate whether sensor data should be included in processed output, we filter out variables during data processing. This is very useful for glider data, as there are hundreds and sometimes thousands of variables in the raw data. Sensor models also have optional inputs for validation, which allow us to flag or exclude invalid data during processing. Using the start and end dates on platform deployment models, we can automatically trigger processing of real-time data for our active missions. So our data processing pipelines generate data files in netcdf format, which allows us to include both the process data as well as metadata in one file. Collections of netcdf files are then served as continuous datasets through our ERDAP dataset catalog. Metadata displayed on our websites is pulled from our ERDAP datasets, as well as directly from Sensor Tracker in some cases. We've also found that custom database queries, if you're comfortable issuing queries directly to the database, can be useful to get information relevant for reporting purposes, such as the total distance traveled by our gliders or the total days at sea. This is a diagram of our glider data pipeline for both Slocum glider and wave glider data. There's a lot going on in this diagram, but the orange box shows where Sensor Tracker fits into this pipeline. We're going to focus on just the flow for real-time Slocum glider data, so the orange arrows here. We have a callback server labeled Slocum Data Server, which runs the Slocum Fleet Mission Control Server software, or SFMC. This allows glider technicians to monitor and pilot the gliders as well as provide access to real-time data to our data managers. Before a mission begins, glider technicians ensure Sensor Tracker is up to date and has all the required information about this platform deployment, and they also upload the cache file to SFMC, which is needed to decode the data files. Slocum gliders transmit real-time data logs over Iridium satellites to our callback server when they surface. And on a separate server, the glider data pipeline periodically looks for active missions based on the start and end dates, and checks the callback server for any new data files related to active missions, downloading any new files. As new files are found, they're parsed to ASCII files by running executables provided by Teledyne Web Research, which requires the uploaded cache files. The pipeline uses the Sensor Tracker client library to programmatically fetch metadata in JSON format from our Sensor Tracker server. This metadata is used to filter and convert variables in the ASCII data files. Then the resulting process data is combined with relevant deployment metadata into a netcdf file. In order to make our process data easily accessible, we serve our datasets on an ERDAP dataset catalog. This involves uploading the data files to the server and creating a dataset configuration file, which identifies the files that should be included in that dataset, as well as metadata gathered from Sensor Tracker and static files. We do plan to relocate the metadata that is in static files currently to Sensor Tracker in the future. What types of metadata are supported? So I'm just going to quickly go through at a high level what information can currently be captured in Sensor Tracker, which is more or less in the order that you would be creating records of these types. A detailed list of what properties are available within these models will be in our repository documentation and updated as we add new fields in response to our users' needs. If you happen to notice that there is useful metadata not currently captured with our available fields, we would appreciate it if you reached out to us to discuss this need. So, for general types, we have institutions, so who is responsible for a deployment or who owns the platform that is being used in that deployment, as well as manufacturers. So this could apply to, say, an instrument or a type of platform. And then projects, so the purpose of a deployment's data collection. So we have platform types, so categories of platforms that we have, like we have multiple types of Slocum gliders in our fleet. So in this example, Slocum glider G2. We also record platform power types, since it can be useful to refer back to what type of battery was used in a mission, especially if there were issues or differences in performance. And of course platforms, so one of our Slocum gliders is called OTN 200, and platform comment boxes are basically a list of dated comments where you can make notes about the platform, more general notes, so like maintenance. And the platform deployments, of course, so mission information, which includes at minimum a start date and an end date for once the mission is completed. And as I mentioned before, we use these to automatically trigger real-time data processing. And then there are also comment boxes for the platform deployment. So again, dated notes, same format, but different purpose. So we could use that to report on events during the mission. And of course, instruments. Then we have instrument on platform history. So this is a relationship with a date range that says when the instrument was on the platform. Similarly, we have comment boxes for instruments, which you could use to make notes about calibration. Sensors, sensor on instrument history, same idea, a dated relationship between those two. Now, how to use the web interface. So we use the standard Django web interface for this website. So if you've ever seen the admin section of a Django site, this will look familiar to you. The interface is composed of a home page which lists all the model types, both the default Django models like user and group for permission control, as well as the custom models that we have added. In addition to the metadata models, the home page shows a list of recent actions by your user that happened through this web interface. Custom models can be organized into categories. For example, general, instruments, and platforms, so those blue headers that you see there. We might decide to reorganize a bit, maybe pulling sensors and sensor on instrument history out into a sensors category, but this is what we have for now. From this list of links, you can access lists of records for each model with the ability to sort by columns, apply predefined filters, and perform search. So this is the default view if you go into platforms. At the top is the text search box, and underneath that is the action list, which is a customizable list of actions that can be applied to one or more records here. On the right side, you have the ability to create a new record of this type, and below that is the predefined filters. So here's an example of sorting by columns. So you can actually sort by more than one column. In this case, we're sorting first by institution and then by name descending. This is an example of the predefined filters being applied. So in this case, only platforms of type Slocum Glider G3 are shown here. And then you can just click all to clear that filter. So this is an example of the text search function. Basically how it works is it searches through all of the columns for all of the records and filters it down to records where that appears anywhere. So in this case, Fundy is the only platform where 670 appeared in one of its columns. Now, from any of these list views, each record links to a detailed view of the entry, which will appear as an editable form if you have write access to that model type, giving you the ability to update it or delete that entry. And if you don't have write access, then it'll show the same properties, but it'll just be all read-only. Here is an example of a form for viewing and updating an existing instrument. These views are, for the most part, automatically generated based on class definitions related to the model types. The reduced overhead in adding new fields is part of the reason we selected Django for this application. We do use some custom templates in our views, mostly to show related model information. So on the instrument detailed view, for example, we have a table that shows all of the instrument on platform relationships and all of the sensor on instrument relationships. How to use the API. The Sensor Tracker server has built-in interactive documentation for the API using a tool called Swagger, which I highly recommend for generating API documentation. It has a really nice UI that's easy to navigate and helps users understand how to correctly use a complex API. For each custom model type and operation, there are API endpoints, so basically those blue and green lines in the lower screenshot there. So the calls include get calls, which are to retrieve a list of entries filtered by query parameters, or to get a single entry by a unique identifier. Post allows you to create a new entry for that model type, or to delete an entry by ID. Put allows you to replace an existing model entry. And patch is similar to put, except that it doesn't replace the whole model. If you only specify certain properties, it will leave the other properties intact, whatever value they already had. The API does not need authorization for GET calls, since they're just read operations, but for any write operations like post, put, and patch, you do need to provide authorization. If you're testing the API through the Swagger documentation, your Django user session will be used for authorization automatically, so you don't have to specify anything explicitly there. But if you are using the API outside of this, either hitting it directly or using the Python client library, then you'll need to provide authorization details in your REST calls. When executing calls to the API, the response to your queries will be displayed in JSON format. So if you look on the right there, the response body, that is an object of key value pairs, and that's basically the JSON format. If you dig down into an endpoint, then you can see the purpose of that endpoint as well as the query parameters available with information about each of them. And if you click try it out, then these fields will become editable, and you can actually test this endpoint directly from this form. So in this case, I'm going to get deployments which have platform OTN 200 involved. And one interesting thing here is the depth property. So by default, the depth is 1, and this will give you a normal record like it would appear in the database. So for a related model, that would just be the ID. But if you specify a depth of greater than 1, then it'll actually resolve the model associated with that ID, so you can get more information from one call. And when my fields are ready, if I click execute, then you can see the result of that query in this response body. And it also tells you what the request URL would have been for hitting that endpoint, so it automatically strings together the query parameters into the URL, and conveniently gives you a command line curl operation that you can use with the token that you require that it's getting from your Django session built right into it. How to use the Python client. Sensor Tracker Client is an installable Python package. Once installed in your environment, you can import the library into your Python code, so that first line there. In order to use the client, you need to specify where your Sensor Tracker server is hosted, so the URL for your Sensor Tracker website, essentially. And that'll let it know how to find the API. If you plan to perform any write operations, as I mentioned before, you need to specify some sort of authorization, which in this case is token, but you can also use username and password. We recommend using token because it's easy to generate new tokens and make old tokens inactive in case you think they're not secure anymore. Much easier than changing password. Here are a few examples of GET operations that can be performed on the instrument model. These examples are not exhaustive. There are many query parameters available, and you can refer to the API Swagger documentation for options and how to use them correctly. But just to give some simple examples, if you wanted to, say, get all instruments from your database, then you can reference the Sensor Tracker Client object dot whatever the model type is, in this case instrument, dot the call type, which is get, and then omit any parameters since we don't want to filter it at all. And the response object will have a list of all results. If you wanted to get a single instrument with a particular ID, then instead of passing in an object, as you see in some later examples, you would pass in the ID number directly, and that'll return a single object rather than a list or an array. And if you wanted to get all instruments which have identifier sci_vmt, that is the syntax you would use for that, and that again will give you an array of results. And if you wanted to get all instruments that were ever on a given platform, then there's a few ways to do that. You could provide the platform ID, or alternatively you can give the platform name, since that also has to be unique. So in this example, we can get all instruments that were ever on our OTN 200 slocum glider. If you wanted to get all instruments that were part of a deployment, again, there's a few ways to do that. You could give the deployment ID, or you could narrow down which deployment it is by giving the platform name and the start time of the deployment. And the start time has some flexibility, like you can just specify the date of the deployment, or you can give the date and time. Sensor Tracker is yours to use. It is freely available to anyone that wants to use it. There are two repositories for this software package. One for the server, which is the website, database, and API portion, which you will absolutely need. And the other repository is for the Python client, which can programmatically interact with your server. Many of our current users, our team included, are on the Ocean Gliders Canada Slack workspace, the instant messaging platform. We have a channel called Sensor Tracker, and we use that to discuss this package. You can use it to ask questions about installation and setup, and just learn about how different teams are using Sensor Tracker to manage their metadata. CEOTR is currently hosting a few different instances of Sensor Tracker for other glider groups, and we do have the capability to host others if that is something you're unable to do yourself. So we're always looking for more users and feedback on our tool. We also welcome direct contributions to our code repositories. For now, our future plans include introducing dynamic visualizations to expand beyond the basic Django interface. We would like to have a diagram of equipment configurations so you can see at this time what instruments were on a platform and what sensors were on those instruments in one visual. This is a work in progress. We'd also like to have timeline graphs of equipment relationships, so what a given piece of equipment was connected to over time. To ease data entry, we would like to add some common, though not native to Django fields like type ahead drop-downs, so it's easier to make selections from a long list of options. And we're aiming to have the ability to store all of the required variables for the Ocean Gliders 1.0 data standard and for the CEOS metadata profile, CEOS being the Canadian Integrated Ocean Observing System, once the requirements for these are finalized. The biggest piece of work we have planned is adding instrument calibration history, which we currently handle separately in our data processing pipelines. For now, it's possible to note some calibration info within instrument comment boxes, but if you do it that way, you would need something custom to parse this freeform text. Fortunately, we have recently gained more active users, and this has led to interesting discussions on other potential uses of Sensor Tracker. One example is the addition of metadata about processed data. So, for example, what calibration info was used in processing, or calculated values like the distance traveled by gliders. Another feature we're considering is the ability to add custom fields, something that would ideally be controlled by an admin so there's consistency within a group. Our hope is that widely applicable fields would become feature requests that we could make available to all users, and that this customization option would be used for specific needs of a particular group. Another idea that came up was the ability to save custom database query commands to easily repeat queries, perhaps with different variables, for reporting or other informational purposes. This could even be used by people who aren't comfortable crafting database queries themselves. They would just need someone to provide the syntax to save in their own query list. So that's it for our presentation today. We'd like to thank Meopar and Laura in particular for organizing this webinar for us, and thank you to everyone who was able to join us today.
Thank you very much, Kate. We really appreciate that presentation. I know the future plans look really exciting, and at the Meopar office, the virtual office, we were just discussing the other day the need for more automation has really come up with the COVID situation, and it just seemed like the way of the future. So we really appreciate this informative presentation. And if anyone has any questions, we invite you now to put those in the Q&A box. If you kind of float your mouse over the bottom of the screen, you should see Q&A, and you're welcome to do that. And like I said at the start, Adam Camo and Kate are available to answer questions. And I see we have a question from Adam. Thanks, Adam. So I'll read that out. Will the platform comment boxes include the scientific purpose behind the deployment rather than just who's funding it? Or is that already included in another metadata field?
Thanks for that question, Adam. So there is a comment on deployments, just like a single comment box. So the comment boxes are more of a dated list of comments, but on the deployment, you can add whatever other information in a free-form text field to explain that purpose.
Yeah, thanks for that question, Adam, and thanks, Kate. And one thing that I was kind of wondering is there a way to export this information, like export metadata to other formats?
So that's something that we are working on right now. From a previous discussion we had on this, there was a need for CSV files. So even just being able to take those tabular views of the lists of instruments and export that to CSV. So we are working on that right now and considering, what other formats might be useful to export. But if there is a format we're not currently covering, you could generate that yourself through the API or using the Python client library to export.
Okay, great. Thank you. We do have a question. This might be more of a question for Adam. What should we do with flight variables such as heading, roll, internal vacuum, buoyancy pump, etc.? Should we create instruments for each internal component? And Adam, I don't know if you want to take that.
Yeah, sure. So yeah, like the gliders record lots of internal flight parameters, and whoever sets up Sensor Tracker can choose to set it up their own way. But the way that we've chosen to do it at CEOTR is that we since we don't know the serial numbers and the model numbers and all that of all the different instruments that create our compass variables and whatnot, we've chosen just to lump it all as like a flight instrument. So we generically create a flight instrument. It's got the serial number of the glider, and we just lump in all of those variables into that one so that they're all accessible at one place. And then we can, it just makes it easier for us to manage those wide variety of variables.
Great, thanks, Adam. That's really helpful. We have a question from Dave. He says, hi, we at BIO have been trying to decide how to use this format for multiple types of deployments. We have some examples of what goes into what item. I think it would be nice to have examples for people to have an idea of how to set up their configuration. We have ideas for using our gliders with their sensors, etc., and another for a CTD 9+ on a cruise. Thanks, Dave.
Sure, I can take that one. Yeah, I definitely agree with you. There is a way through the API to see how we've set ours up, since, like I mentioned before, with the GET calls, you don't need authorization. So it is possible for you to get that information, but I think we could probably find a way to provide easier access to look into how we've chosen to set ours up. So that's definitely something we'd want to do. And then probably add just simple, like a setup flow. Like here's how we initially went through adding a sensor, an instrument, and a platform, and then ultimately platform deployment. We could include that in our documentation. That's definitely something that would be worth adding. Thanks.
Thanks, Kate. Yeah, thanks, Dave. That's a great recommendation. And coming from the education world, I'm a big fan of exemplars and examples. So thank you for raising that. Another question that has come up is how should we handle instruments that don't have sensors, or maybe where we don't care about the data, but still want to include that information in the deployment metadata? I'm not sure who, perhaps Adam would answer that.
Sure, yeah. We do this for our Slocum glider missions where we want to keep track of, for example, a motor that's getting use, and we need to keep the number of days at sea that it was moving, so that we'll know when it's time to finally send it away for servicing. So what we do is we just create an instrument and we give it the serial number of that motor. We provide as much information as we can, but we don't put any sensors on it. We just track the instrument, and we can provide general comments of the instrument, or even instrument comment boxes, so time-dependent comments such as calibration information. So we can keep track of all this stuff with Sensor Tracker, but not necessarily need to have that sensor report any sensors or data variables that are used in the processing.
Great. So it's a pretty flexible system that way, it sounds like.
Yeah.
Thanks, Adam. That's great. If there are any other questions, feel free to type them into the Q&A box. And we'll just give people another moment to do that. And Kate and Adam, I think you mentioned that there was someone attending the webinar who has a very strong connection with the software.
Yeah, I believe that, well, assuming he's joined us, I haven't seen the full list of attendees yet, but oh yeah, he is there. Hey, Brad. I believe that he was working on this before I joined the team, so he probably knows as much about it as I do.
Nice to see you, Brad. Thanks for joining. That's great. Yeah, it's I have to say we've had a very high attendee rate for this webinar, so I want to thank everybody for taking the time. I know there's a lot going out, going on with webinars and working remotely. We do really appreciate people taking the time. If you do have any questions for Kate and Adam, feel free to put them in the QA box now. We'll keep that open for a few minutes. You can also follow up with us. Like I said, we will be sending out the recording and links to the repositories. And I know myself, I'm really excited to learn more about this. I do think that we're going to see more and more automation in the marine field, and very excited to see where that goes. Oh, and here we have a question from Adam. I think it would be useful to include metadata on the weather conditions upon deployment and recovery, and any biofouling of the instruments or gliders that is apparent upon recovery. So he asks, is this something already included, or are there plans to include it in the future? Maybe some sort of photo repository would be useful for the latter.
I could take at least part of that. I think at present, well, we don't have explicit fields for some of the things that Adam mentioned, but we do have a few deployment and recovery fields already for other things, but you could use the platform deployment comment boxes to type out, information that happened at the beginning and then do the same thing again. And based on those dates, you'd know it was pre and post deployment information. And and about the photos, I believe we do already have an ability to attach photos to platform deployments. That was a fairly recent feature.
Yeah, and if I can just chime in here quickly, and we wanted the feature to add photos, you know, to take a picture of what the glider is, so you could actually see, or how the platform that's being deployed is set up, so you can actually see where your sensors are in relation to each other. I think it's really important to know, you know, your sensor was in the front or in the back, and just having a picture was really useful for that. Taking pictures afterwards for the biofiling is a great idea, and it's something that we historically did in the old Excel spreadsheet days, but it's something that will ramp up again to do it with sensor tracker, so that they can be logged there. It's going to be the better spot to store these photos. That's a great idea. Thanks.
Yeah, thanks all. Thanks, Adam, and Kate. Perfect. And Adam just notes, that's great to hear. Thank you. Well, I think we're going to wrap things up now. I would like to once again say thank you to Kate and Adam for, you know, taking the time to organize this webinar, share the potential and the power of the software with us, and really excited to see further developments. It sounds like the future plans are there's a lot of exciting things in the works. And thanks everyone for joining us. We do hope you enjoyed today's webinar. Please follow Meopar on Twitter and check out our events page on our website at meopar.ca. Our next webinar will be held on May 7th, and we'll be discussing results from the Atlantic Canadian Microplastics Project. So feel free to share that with colleagues who might be working in the microplastics field. So once again, thank you, stay well, and have a good day.